Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about two sample...
Hey Jared, dinner's ready.
Mom, I told you not to come in the basement when I'm filming for my class.
Well, I made your favorite. It's spaghetti tonight.
Ooh, spaghetti. Welcome back to Morehouse's Math Menagerie. Today we're going to talk about two sample significance tests with paired data. Let's go to the PowerPoint. In our last video, we talked about inference for two means with independent samples. Today, we're going to talk about what happens when your two samples are not independent. It's always nice to have some context for these discussions, so let's look at a scenario. Researchers are interested in the reaction time of students using their right and left hands. The data was collected from 5 students and is presented here in our table. We have here two separate samples. However, it would be hard for us to justify that these are independent samples. If a person tends to have a faster reaction time with their right hand, they probably tend to have a faster reaction with their left hand and vice versa. So these are dependent samples. In order to address the lack of independence, what we're going to do is pair up each of these values from the students, their right hand and left hand reaction times. We're going to subtract them and make a list of differences. So here we have the difference between this student's right hand and left hand, and the difference between this student's right hand and left hand. Now, I chose to subtract from left to right, so I did right hand reaction time minus left hand reaction time. Usually, you want to subtract in the order that it's written in the problem. However, the direction's arbitrary. We could choose to subtract in either direction. We are going to treat this list of differences as a single data set, and we will run all of our hypotheses tests and our confidence intervals on it, just like we did when we had one sample for means in section 8.3. So our hypotheses are going to be run on what's called mu sub d, or the mean difference. So the null will be often that the mean difference is equal to 0. The alternative will be the mean difference is less than 0, or greater than 0, or not equal to 0, depending on the situation. The formulas we end up using are the same as those we used in 8.3 when we did confidence intervals and significance tests for one sample means. Our t-test statistic just takes our x bar minus our mu and divides it by the standard error of the sampling distribution. That t will still have a degrees of freedom of n minus 1. For confidence intervals, this should look very similar again to the formula we used for one sample means. All right, let's jump into the homework and work a few examples. Okay, let's read number 4 together. It says, listed below are the numbers of words spoken in a day by each member of 8 different randomly selected couples. Complete parts A and B below. Now here we have a list of words for males and words for females. These are not independent samples because the male and females come from specific couples. So it would be hard for us to say that if a wife talks more, the husband wouldn't also talk more, or vice versa. So these are dependent samples. They want us to use a 0.01 significance level to test the claim that among couples, males speak fewer words in a day than females. In this example, mu sub d is the mean value of the difference d for the population of all pairs of data, where each individual difference d is defined as the word spoken by the male minus the word spoken by the female. That's really nice. They tell us explicitly which way to subtract. What are the null and alternative hypotheses for the hypothesis test? Well, the null is always an equals to, and if they were the same, the mean difference would equal 0. If males speak fewer words than females, then we would think this difference for the alternative would be less than 0. We would think it was negative. Let's check that. All right, they like it. Let's look at our test statistic here. We need to go into StatCrunch and find our differences. Here's our two data sets, but we're not running the test on the two data sets. We're running it on the difference in the two data sets. So select the first column or the first cell in the var3 column here, hit data, compute expression, and then I like to hit this build button over here because it has some nice features. We can double click on male, and then I'll put male up here, minus, and we want to subtract the female, so I'm going to double click on female, hit OK, and compute, and it fills in this column, it fills in this column nicely with all of our differences. Now we can run our hypothesis test on our data, or these differences. So I'm going to go stat, t-stats. This is one sample now, and we have the data. Let's select my column with my data in it. We said the null was an equal 0 and the alternative is a less than 0. We're going to hit compute, and it gives us our t-stats and our p-value here. So for t, they want 2 decimal places, so negative 0.43, negative 0.43, hit enter. That's good. For our p-value, they want 3 decimal places, so 0.339, 0.339, enter. Nice. And our p-value is greater than our significance level. They had a significance level of 1%, and we were at pretty much 34% for our p-value. So we're going to fail to reject the null hypothesis. There is not sufficient evidence to support the claim that males speak fewer words in a day than females. All right, let's check our answer, and we feel good about that. Now they want us to construct a confidence interval that could be used for the hypothesis test described in part A. What features of the confidence interval leads to the same conclusions reached in part A? We had a 1% significance level on a one-tailed test. That means that the left tail, the less than, was a 1%. We need to mirror that over to the right tail and have it be 1% as well. So we're actually finding a 98% confidence interval here. So let's go back to our options. Let's edit this and change this over to a 98% confidence interval. We're going to hit compute, and we get our limits here. I'm going to copy this. It wants it to the nearest integer, so I'm going to copy this and paste it in there because it's kind of a long number. I can't remember that many numbers. Let's copy this one as well. This one we're going to have to round up to 9257. 57. Check our answer there. It likes it. Nice job. What features of the confidence interval leads to the same conclusion in part A? Well, you'll notice that our confidence interval contains 0. So 0 is a possible mean difference for these data sets. So we're going to say it contains 0, and so we fail to reject the null hypothesis. Nice job. Okay, for our second example, I want to do number 5. This is dealing with the same situation we discussed in the slides with reaction times. But let's read through it together anyways. Several students were tested for reaction times in thousands of seconds, using their right and left hands. Each value is the elapsed time between the release of a strip of paper and the instant that it is caught by the subject. Results from 5 of the students are included in the graph to the right. Use a 0.02 significance level to test the claim that there is no difference between the reaction times of the right and left hands. So for the hypotheses, it says let mu sub d be the difference between the means or the mean of the differences. So it's a little bit subtle. You might think these are the same things. The second one, the difference between means, would be what we covered in the previous section with a mu sub 1 minus a mu sub 2. Here, we're looking at the mean of the differences themselves. So we're going to select the mean of the differences of the right-hand and left-hand reaction times. Our null hypothesis is always an equals to, and they already have a 0 in there as well. Now they want us to test the claim that there's no difference between the reaction times. So they're not saying one is greater than the other, they're just saying not equals to. Let's check that answer. Awesome. All right, now we need to find our test statistic. So let's go ahead and go into StatCrunch with this table. And again, we need to find the differences in our values. So I'm going to select this first cell in the variable 3 column and select data, compute expression. I'm going to build an expression that is right hand minus left hand. I'm going to hit OK and compute. And it fills that column with our differences, and we'll run our hypothesis test on these differences. So now I go stat, t-stats. I'm doing one sample with data. I'm going to select the column that my data is in. I have the hypotheses. These are already set up for us really nicely. The null is that it equals 0, and the alternative is that it does not equal 0. I can hit compute, and I get these t-stats and p-values here. So my t-stat, they want 3 decimal places, so negative 5.641, negative 5.641. I hit enter there. Nice job. Let's get rid of this table here. Now it's asking me for the critical values that we would use in this test. So instead of using the p-value here, we're going to use a critical t-value. Note they want a 2% significance level. So let's go back to StatCrunch. Let's close this out. Go stat calculators t calculator. Now our degrees of freedom are 1 minus our sample size, and I believe we had 5 people in our sample, so minus 1 is 4 degrees of freedom. If our significance level is 2%, that means we want the middle, the between, to be 98%, so 0.98. And this gives me my critical values for my t here. Either one of these, because it's a two-tailed test, if our test statistic falls to the left of negative 3.747 or to the right of positive 3.747, that would result in a p-value less than 2%, and these would be our critical regions, resulting in rejection of the null hypothesis. So I'm going to select here B plus or minus 3.747 and hit enter. It likes that value. Now, in our conclusion here, there is enough evidence to warrant rejection of the claim. Because our t-value is less than negative 3.743, we're going to reject the null hypothesis. So we're saying there is enough evidence to warrant rejection of the claim that there is no difference between the reaction times of the right and left hand. So we're rejecting that there's no difference in favor of that there is a difference. Let's check that answer. Okay, those are the only 2 examples I wanted to run through with you today. Hopefully this is very familiar to you already from what we did in Chapter 8. If you have questions, remember to use this Ask My Professor button. Thank you for joining me. Have a great day.